do the structure. We're going to study the structure of an atom. Okay, we're going to look at what it is really, and also doing the calculations around the subatomic particles. Okay, don't worry, I'm going to explain what I mean by subatomic particles very soon. But essentially, you're probably familiar with this periodic table, so you probably have seen it somewhere. Okay, this periodic table, it has certain elements. We call these elements here. These elements are the building blocks for all matter in our universe. So when we say matter, we actually mean solid, liquids, and gases. Okay. So these scientists have been investigating the structure of an atom for some time, and our ideas got better and better and better over time. Okay. So we use what's called a model. A model, it's a representation of a system in the real world. Okay. If you're doing sciences, then you probably, even humanities as well, anything, you probably are familiar with models. Okay, so we take away the complexity, we explain very well, and sometimes using something that closely relates to a concept that we'll be explaining. Okay, so for the atom, we use one of the models that we use is this planetary model here. We call it planetary just because it's fairly similar to the structure or the functioning of the solar system, where you have the sun in the middle. Okay, the sun in the middle, and you also have these planets here going around the sun. Okay, so in our case, the planets would be electrons. So electrons, you probably are familiar as well with the suffix here. It reminds you of electricity. So the electricity is you can think of it as the flow of electrons. You have electrons here. You also have this nucleus. Nucleus, it also contains some things. The residents of the nucleus, they are called the nucleons. So nucleus, you actually have two stuffs there. You have the protons plus the neutrons. Okay. So all of them, they're called the nucleons. They're called the nucleons. Nucleons means residents of the nucleon. Let me actually write this. Residents of the nucleus. So it's like saying Zimbabwean. Zimbabwean means you live in Zimbabwe. Nucleon means you live in the nucleus. Okay. So residents of the nucleus. My spelling is very lousy, but yeah, this is nucleus. This is how you'd spell it. And the residents of the nucleus, they're called the nucleons. So we actually have two there. We have the protons, and we have the neutrons. You expected to know all. And the protons, the way that you explain them is they're positively charged at subatomic particles. Protons are positively charged subatomic particles. Listen, if you want to recall some of these definitions, it might be simpler than you think. Okay, this is how you do it. The nucleons, by nucleons I mean the protons and the neutrons, and also separately then the nucleons. But essentially the subatomic particles are the electrons, the protons, and the neutrons. So whenever you're asked to define this, any of the three, you have to define to say it's a subatomic particle, and then you have to explain how different it is from the other ones. That's what comprises the definition really. So for example here, it's positively charged. It's a subatomic particle, then we say it's positively charged. Okay, so if it were neutrons, you'd say neutral subatomic particles. Okay, so neutral subatomic particles. You're just putting this qualifier here. It's neutral and it's a subatomic particle. Here, these electrons, you would be saying negatively charged subatomic particles. So there are levels to this. The first level is they are all subatomic particles. So if you're asked what's a proton, what's a neutron, or what's an electron, you say it's a subatomic particle. Then you have to differentiate now. The way that you differentiate them is by the polarity that they carry, the charge that they carry. So For electrons, they carry the negative charge, and for protons, they carry the positive charge. They're positively charged. Okay. For neutrons, we do the root word here, the prefix. It's associated with neutrality. So neutrons actually means being neutral. That's what it essentially means. So these two here, they are residents of the nucleus. So we call them nucleons. Okay. So another way to play around with words, you can actually say positively charged nucleon, defining the proton. Okay, you can actually say this. It's an alternative way of saying this. Okay, so you can say positively. This is an even more refined answer. Charged nucleon, because you have identified that they actually reside in the nucleus as well. So here you say neutrally, or you say neutral nucleon. Okay. Or neutral subatomic particles. Here they don't use this one, but then this one it's really good. Okay, so yeah, all these they're called nucleons. Yeah, nucleon means residence of the nucleus. The nucleus here, it's this thing here, this big thing here, and this big thing it's very dense. Okay, this is just a model, but essentially it's very small compared to the orbitals. These ones they're imaginary lines. Okay, these are imaginary paths that the electrons follow. They are not in the same way that we don't the earth is not moving in any highway, but when we want to describe it, we say it's moving in an orbit. Okay, this orbit, that's what we have. So these are imaginary, but always you find electrons in the areas around the nucleus here. There is some attraction. The nucleus is positively charged. If you're asked, well, the nucleus, what is it? It's positively charged. Okay, so the nucleus is positively charged just because it contains protons. So you have stuff that are positive and you have stuff that are neutral. Positive and neutral, you get positive. Okay, so that's it. So here, this is the nucleus is very small compared to the rest of the atom. The other thing that you have to remember, you have to define. Sometimes you don't have to define it. Usually they ask you directly, and then you have to answer now. Is what is the mass for others? So we say we use what are called relative masses. Let me actually move to the next slide. So now that we have identified the protons, the neutrons, and the electrons, and we have also defined in terms of their charge. So we say that when we need to define them, we use the charge. So the units of charge for the protons, it's positive. Okay, you can actually say positive here. So units, you can say +1 or positive. So neutron is 0, electron is -1. Okay, so this one, and this one, they have the same amount of charge. They have different. So the positive, you can say proton here, associate this p with positive. Okay, then the other one by default would be negative. Okay, and then this one neutral, 0. So this is the unit for. So here, this proton would be 1 atomic mass unit. Okay, so you can even say just 1 here. Then neutron would be 1 again. Electron would be 0. It's not necessarily 0, but you should write 0. You can think of it this way. If I have about $1,890 and you have $1, it means that compared to me, you have nothing. So you have 0 there. So I would say that you have negligible mass. It's not too much to consider. So in that way, we have electrons with 0 here. So these ones, they also have symbols. Okay, they also have symbols that represent them. There's one word that doesn't have any symbol, and this is the electron. Once I explain this to you, I want you to think about why the electron does not have any symbol. But essentially, the proton number, it's denoted by Z. The neutron number is denoted by N, and the electron number doesn't have anything. So Z here, you'd actually expect neutron, it's N. So proton, you'd actually expect it with P, right? Because that's what's logical. But Z, it actually comes from a word called Zahl. So it actually comes from a word called Zahl. Zahl means number in German, and the reason we say, because if you say Zahl number, you mean atomic number. Atomic number is detected by, it's dictated by the proton, the number of protons. So why is it like that? Because of the nature of physical chemistry. Physical chemistry affects everything here. Our physical chemistry affects, well, obviously not the neutrons, it affects the electrons here. So constantly atoms are sharing electrons, they're giving away electrons, they're taking electrons away from other atoms as well. So electrons, they are not a reliable way of uh, gauging someone's identity. Okay, when you find any atom, I'm just saying hypothetically here, if you were to meet any atom, the atom would have, let's say, 3 electrons today, but then if you meet them again after a few hours, you'd see the same atom having, let's say, 5 electrons. Okay, so this is not a very good way of gauging the mass, the identity of an atom. Okay, what we gauge the identity with, it's called the proton. So proton, remember we've defined the proton, but we have to define what's called the atomic number, atomic or proton number. So here, just note that we are saying atomic or proton number just because they are the same. The identifier here, this is the identifier. If I'm meeting any atom, I ask them, what's your atomic number? They should give me their proton number, because that's the identifier. That's the thing that doesn't change. Okay, your birthplace doesn't change. In the same sense, we want to use identifiers that don't change. Okay, it's more complicated than that, but essentially that's what we use. So the proton number is number of protons in an atom. Okay, so the proton number is number of protons in an atom. If you're here studying, what you do is you have seen me, you have heard me say the definition. So you just pause the video and then try to write it on your own as well, on a piece of paper, without looking. And then if you get it right after some time, you actually commit it to memory as well. So that's the proton number. So it's important for that reason that I told you, denoted by Z here. Okay, the other one is the what we call the neutron number. So the neutron number, I'm not going to talk about it, obviously. I'm going to talk about it maybe in part 2, where we study isotopes and all that, for those doing chemistry. But proton number, it's simply the number of neutrons in an atom. Okay, so this two, when you check the mass, you actually see these two have mass. This one, we say, comparatively doesn't have any mass here. So these two here, they form what's called the mass number. Sum of the proton and neutron numbers. So that's the mass number. Okay, so mass number is the sum of the protons and the neutrons. So you'd have the mass number. Let me actually try to relate some of this stuffs to you here. Okay, so here you'd be having so let's say helium. Notice that the way that you write their periodic table is, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, 7, 8, like that. But then when you see the numbers at the bottom here, they are saying 4, then it says 3 here, then it says 9, then it says 11 here. It doesn't make sense at all. So it says 12 here, then it says 14, 16 here, then it says 19. These are mass numbers. So they're not identifiers. The identifiers are these things that are going serially. So you actually have 1, then you have 2, then you have something, then you have 3 here, then you have and so on. So those are the identifiers. Okay, So here 25, 26, 27, just because we are identifying them by this one called the proton number. Okay. So the mass number would be, let me actually move over to some other slide here, which would be more useful. So when we're writing the chemical symbol, this one X, so X would be the identity of the element. Okay, let's say oxygen, so you'd actually put O here. Then A is the number of nucleons. Okay, this is the protons plus neutrons. So A here would be protons plus neutrons. So protons, they are denoted by what? By Z. Neutrons, they're denoted by N. Okay, so we have protons plus neutrons equal to A here. They're also called the mass number. Remember from previous slide, we were saying that only protons and neutrons have mass. Okay, they have the most mass in an atom. And then our protons here, the identifier, we also need it. This is how we would write our chemical symbol. Okay, so for example, let me fetch a very useful example here. So helium, this is just an example. Okay, so let's say hydrogen is 1 1. Okay, so hydrogen, then you say 1 1. It simply means that hydrogen has how many protons? 1. And how many neutrons? It also has 0. Okay, so why? Because Z plus N equal to 1. So this is how we'd write hydrogen. Let me see if I can get another more useful one. So 12 and 24 for magnesium. So magnesium, the symbol would be this, like this. Then the atomic number would be 12. Okay, so first write the atomic number. The mass number is 24, like this. Then you've written. So when you see any element here, just know that the number at the top, it's the mass number. It's the more, it has more, it has more value usually. And then the proton number, it's at the bottom. Okay. So this helps us identify elements. Let's see if we can move over to another slide here. So explain the meaning of each of the following terms. So the nucleus, this is the central part of an atom. Okay, central part of an atom, and it contains neutrons and protons. Okay, if you want, you can even say, and it contains nucleons. And that's it. Electrons, we say they are subatomic particles. So we qualify again and say negatively charged subatomic particles. The atomic mass is what? Sum of the protons and neutrons. So the way that you'd say it, obviously, you'd say sum of the mass of protons and mass of neutrons. Okay, sum of the mass of protons and mass of neutrons in an atom. So in an atom. The reason I added in an atom here is that we also have some other numbers as well. So in an atom here, just because they told you atomic. Okay, so that's it. Let's move over. I think we have something that you can work with here. Great. So here we have our elements. Okay, so for this first part, we are actually given the symbol would be, let me grab a pen that's better here. So the symbol will be Mg here. Then we said we put the mass number at the top. The mass number is 24, the bigger number usually, but not always. Then the atomic number would be 12. Done. Okay, so this is what you'd actually write as the symbol. But then you asked, well, find the number of protons. Okay, so the number of protons is the same as the number of atomic, there's the atomic number, because proton number is atomic number. So you can actually go and say 12 here. 12 here, obviously 8. 17 here, you can actually write 17 here, as if you're playing a puzzle. So here I can actually write 13. The atomic number and the proton number, they're always the same. Okay, so number of electrons in a neutral atom. How do we know when an atom is neutral? It's uncharged. Okay, so just like what I was telling you, that atoms are constantly receiving and sometimes transferring electrons. So sometimes you have to know when an atom has transferred any of its electrons. But a neutral atom has zero charge. But then how would you identify a neutral atom? Because it doesn't have, we see here, this aluminum is Al, then 3 plus. This 3 plus here is the charge that we're talking about. Okay, so if it doesn't have any charge here, magnesium can actually be Mg2 plus. Okay, but then here we asked for magnesium just Mg. So what you do is the number of electrons must be equal to the number of protons. So for a neutral atom, so you want to neutral atom number of electrons equals number of protons. Okay, so for a neutral atom, this number must be the same. So Mg, we check there's no charge here. So Mg, number of protons must be equal to number of electrons. So it should be 12, 12. This one O is neutral again, so must be the same again. So this one must be 8. This one we don't know it yet. This one is neutral again. I'm just playing jigsaw here. This is nickel, it's neutral. So if it's neutral, the number of electrons and the number of protons, they must be the same. So here we're given the number of electrons is 28. This one must also be 28. This one we don't know, this one we don't know, this one is carbon. We're given number of electrons is 6. It's neutral because we don't have any charge here. So the number of protons must also be 6, like this. Okay, let's move over to the first part. The first part says the last bit of the first part. So it says number of neutrons. Number of neutrons. Okay, so neutron number it's n, remember. So we said nuclear number, which is A, equal to number of neutrons n plus atomic number Z. Okay, so here atomic mass units here, they're denoted by A. Then atomic number, it's denoted by Z. Okay, then everything else you can just leave it like that. So number of neutrons would be n. That's what we want to find out. We have A is equal to 24 plus our Z is equal to 12. So you transpose this one to the side, then you actually get 12 here. Okay, so this one will be 12. So A is equal to n plus Z. A is equal to n plus Z. A is the mass number here. So let me actually write it. Mass number, and then n is the neutron number. Z is the proton or atomic number. Proton number. Okay, so you can do the simple calculation, then you find out. And also for this one, let me actually clear some space here. You can copy it obviously somewhere. And here it says number of neutrons. So again, A is equal to n plus Z, and then what do we know? A we don't have here. Okay, so atomic mass units we don't have. What we have is n, which is number of neutrons we don't have. We're still to find out. Then Z, which is proton number, we actually have atomic number is 8. Okay, so oxygen 8, 8. So the mass number equal to number of. Okay, so here we were kind of stuck because we don't know the atomic mass, and to know the atomic mass you need the neutron number, or to know the neutron number you actually need the atomic mass. Okay, so what you do is you identify the symbol. The symbol is what? Is oxygen. Let's go look it up. Where is oxygen? It's here. Okay, your periodic table might actually look a bit different depending on what you're using. So your periodic table might actually look a bit different. Okay, but essentially this is oxygen. I'm trying to write here. So essentially this is oxygen. Okay, so oxygen, we have atomic proton number is 8, and mass number is 16. Okay, so you go back, you put your mass number there. Let's actually go back. Our mass number is 16. Okay, so our mass number is 16. So where is it? Our mass number is 16 here. So now we have number of, we said A equal to Z plus N. So now we have A equal to 16 equal to Z is equal to 8 plus N. So N is equal to 16 minus 8, which is equal to 8 here. So we get number of neutrons as 8. Okay. This one, next part, it's a bit tough as well. So here we don't know the symbol, but what we know is the atomic identity. This is similar to your ID number on your ID, okay, on your national ID. So here you have 17. You can actually use this to go and identify what element we're talking about. So let's do that. 17. So here 14, 15, 16, 17 is chlorine. Then you go back. Okay. Then you write this one must be chlorine. That's the symbol. And we're also going to write the symbols at the end in the standard notation. So atomic mass number of chlorine here, number of electrons. This atomic number, it obviously means that it's chlorine. Okay, number of electrons, since it's just neutral, we say it's 17. Okay, so this part is done, and mass number we have to look up as well. It's just like what you did the last time. So mass number of chlorine is 35.5. So you go back, you write here 35.5 like this. So now you say 35.5 minus 17. So 35.5 minus 17. So you get 18 and a half, so 18.5. So the reason you have, it's not that you have a neutron in half. No, it doesn't mean that. We take averages. Okay, chlorine actually has several, we call them isotopes. This is beyond our combined science, but essentially these are average numbers that we're dealing with. But all the atoms or elements that have atomic number 17, they are chlorine. There's no question about that. Okay, but then the neutron number can be different, and so we take the average. So the average in our case, it's 18.5 for our case. So here we started by identifying the mass number from the periodic table. Let's move over to nickel. Nickel has proton number and electron number of electrons. So here it was neutral, so that's why we said, oh, the proton number must be the same as, and we also insist again to say the proton number equal to the atomic number, which is 28 for our case. It's also the same thing here, would be 6. So now we have nickel, we have these details here. Again, we have to go back to our periodic table and then identify what's the atomic mass of nickel. So here you have identity 28. So ID 28, it's this one here. So it says ID 28, it's this one here. Where is nickel? It says 59. Okay, so you go back again, and you say 59 here. Once you have 59, you have to go back again, work it out, and say A, which is the mass number, equal to Z, which is the atomic number, plus N, which is the neutron number. So A mass number we're given as 59. So Z we are given as 28 here. We calculated, I mean, as 28. Then plus our neutron number, which is N. So N is equal to 59 minus 28, which is equal to, so 59 minus 28, you get 9 minus 8, you get 1, then this one you get 3. So you get 31. Okay, so you go fill up. And then here we have atomic mass number, mass units of 20. Number of neutrons, you have 20 here. This one is a bit tricky, okay? But let's figure out what's happening. You have number of neutrons, that's N. So you have A equal to Z plus N, just like what we are doing here. So you have our A, we have 40 equal to Z, okay, plus N. N is what? Is 20, number of neutrons. So Z equal to 40 minus 20. So it actually get 20, like this. So Z is the atomic number. It's also equal to the number of protons as well. So 20. So here, number of electrons you can actually write as 20 as well, assuming that it's a neutron atom. Okay. Then what you do is go ahead and identify. Now we're looking for, you can also verify to say, okay, is the mass 40 really, or is it close to 40? Sometimes not always the same, but is it close to 40? So our atomic number is 20. Let's take that ID number and then go and identify. So 16, 17, 18, 19, 20 here, calcium, you see? It's even got 20 and 40 mass number. Then you go back. You go back and you write your mass number, your atom as calcium, because you figured it out. Now zinc, it doesn't have any details. So you go to your periodic table. You have to find now using that symbol zinc. So Zn here is Zn. So what you get from here is you have Zn. So here you have Zn. Then you have the mass number, it's 65. And atomic number, it's 30. Okay, this is what you'd see in some periodic tables. So mass number is 65, proton number is 30. So 65, 30. Then you go back, mass number it's 65, proton number it's 30. So 30, we say this is the same, 30. In a neutron atom, this is the same, 30. Okay, so number of neutrons. So here you have your mass number is 65, so which is A, 65. Your Z, which is the atomic number, is 30, then plus N. You have to find N here. So N is equal to 65 minus 30, which is equal to 35. Okay, so you write 35 here, done. Then here, number of neutrons, you have 0. So you have to figure out again, go and do your Sherlock Holmes. Which one is number of neutrons 0? So this one is number of neutrons 0, hydrogen. Why? Because hydrogen is 1 is its mass number, and it also has 1 is its atomic number. So that mass number and the atomic number, it signifies that the hydrogen atom comprises essentially of a proton only. Okay, so it's a proton, and an electron obviously in its orbit, but it's a proton only, so it's 1 mass number. And another way to think about it is to say, okay, the atomic mass equal to Z, which is the mass number, which is what the Z, which is the atomic number. So we don't know that, so we can say, yeah. So atomic number, it's 1 here. So atomic number, so you can say A equal to Z plus N, like this. So Z, which is atomic number, it's 1, and A, which is the mass number, it's 1 plus N. So obviously N is equal to 0 here. Okay, so that's why we write That's why we got 0 on this point here. So number of protons, same as atomic number, and the number of electrons for a neutral atom, same as, and then that was hydrogen. Okay, so carbon, we had finished almost everything except for this part. So A again is equal to Z plus N. So your A is atomic number, which is 12. Your Z is 6 plus N. N is equal to 12 minus 6, which is equal to 6. So you have 6 here. Okay. So let's go to the tougher ones. So for the atomic number, we say that it doesn't change. Okay, so it's this. Right. Here's the difficult part now. So atomic number is 13. At atomic mass, we don't know. Number of electrons here would be different because we have 3 plus. 3 plus, it means that we have 3 more than. You can think of it as, you can say proton plus electron equal to charge. Okay, overall charge. So overall charge is what? 3 plus 3, or 3. Okay, let's just write plus 3. So number of protons does not change. Okay, the proton number does not change. It's always the same. It's what? It's 13 for our case. So 13 plus E. So E is equal to plus 3 minus 13 is equal to minus 10 here. So you'd actually get 10 here. 10 is in 10 electrons. Okay, electrons are negatively charged, so you have 10 units there. Okay, so P plus E equal to charge. This one right here. P plus E equal to charge. Okay, let's try it for this one here. So P plus E equal to charge. So our charge is minus 2. Now number of electrons is 810, so it's negative 810 because electrons are negatively charged. Okay, so it's negative 18 P here. So P is equal to negative 2 plus 18, which is equal to what? 16. Okay, so you actually write 16 here. We say this one is the same 16. Then the mass unit, the mass here you have to look up. So for aluminum and for oxygen. So for aluminum, what is it? Where is aluminum? Here it's 27. So this one is 27. For oxygen, it's 32. Okay, so you look up on your periodic table, you'll be able to find. And then to get the number of neutrons, again from here, number of neutrons would be equal to A minus Z. So A here, 27 minus 13, you get what? You get 14, right? 14 plus 13, you get 27. So here again, you say number of atomic number, which is 32, minus atomic mass number, which is 32 minus 16. Then you get 16. Then yeah, that's it. So what we're going to do is I'm going to put a quiz. Now we will be working with our website. So I'm going to put some questions for you there. You can go and you can answer and you can get your paper graded instantly. Okay, so we're going to put for every unit that we're going to cover here. So just go on primaEd at primaEd.com. And then you'll be able to write some tests. So for this one, you'll be able to write this for a test on this one after about 2 days. Okay, so just check out that space, check out the space and try out the quiz there, so that you gauge yourself whether you're actually understanding the concepts or not. So that's it. I'll catch you in the next video.